Okay, so this is question 2 in our trying to figure out Hess's law calculations. And it is asking us for the heat formation of ethane. So again, when we are drawing these, we are doing our arrow, we are going C2H6, and then we're figuring out what are my elements in their standard states. So I must have 2C, and to get H6 I must have 3H2. Okay, so that is my top line done. It then says write balanced products of combustion for the biggest compound. So again, we have this written over here. So I'm writing my products with the down arrow, and in this case I'm going 2CO2 plus 3H2O. Now you might be asking, why am I ignoring the oxygens in the heats of combustion? Well, oxygen is an element, even if it's written as O2, and the rule is the enthalpy of formation of elements is 0, so it would cancel itself out. So that's the reason why we're ignoring it. So we then go to label my joining down arrow with its enthalpy value, so that, and its number. So there's only one of them in this top line. So it's going to be 1 by minus 1559.8. We then say look at other components in equation and label their down arrows. So I'm going 2C, but over here I only have 1C. So my number is going to have to change. So it's going to be 2 multiplied by minus 393.5. And here for the hydrogen, in my heat of formation equation here, there's 3 H2s, so it's going to be 3 by minus 285.8. Now, again, it says use the direction arrows to figure out how we write our Hess's law. So, see here, red and red, they are going to be one part of our Hess's law, and here the blue and the blue are going to be the other part of the equation that we're trying to write. So I apologize, I never put my delta H here. So we put it all together. Delta H plus 1 by minus 1559.8 is equal to bracket 2 by minus 393.5 close bracket plus bracket 3 by minus 285.8 close bracket. Now, I've said normally any calculations, if you've watched my videos, we don't change anything, we just rearrange, but we are going to solve this part here. So plus by a minus is a minus, and 1 by 1599 is minus 1559.8, and then we finish it again. Now you might think it's a bit of a waste of time to keep rewriting things, but actually you've less chance of making a mistake if you rewrite it out, obviously copying it exactly. So I wanted to put this 1.599 to the other side of the line, and to do that I need to add it to both sides. Now I'm ready to go. So we've written our Hess's law. We're ready now to actually do the solve part. So we plug it into a calculator, and when I am done, my delta H value in this instance should be minus 84.6 kilojoules per mole. Final answer.